Now we are doing a chapter summary for chapter 2, that is kinematics of linear motion. So for chapter 2, basically we have 3 subtopics, that is 2.1 linear motion, and then 2.2 uniformly accelerated motion, and last one is the projectile motion. We just go to the basic things that we have to know for the chapter. That's why we call it as a chapter summary. So basically for 2.1 linear motion, the most basic thing that you have to know is, the first one is the displacement. When we talk about motion, we have to know the displacement, velocity, and acceleration. Okay, and the basic equation or the basic formula for the velocity is displacement over time, and the basic equation for acceleration is velocity over time. So this is the most basic thing that you have to know for 2.1. Okay, you can go into detail by referring to your lecture notes and any reference, but for this chapter summary we only go for the basic one. And for the subtopic 2.2, linear kinematics equation, linear kinematics equations. So it is actually just the same as what you have learned from your secondary school. We have 4 basic equations for linear motion, that is v is equal to u plus at, v squared is equal to u squared plus 2as, s equal to ut plus half at squared, and last one is s equal to half u plus v times t. So that is uniformly accelerated motion. And for the last one, that is subtopic 2.3, we have projectile motion. So our projectile motion is depending on angle. Okay, so if our angle is 90 degree from the horizontal, so let's say the motion is upward here, and it is in the air. Okay, your object is in the air, so we call it is moving under, as the motion is a projectile motion, so we call it the motion is under projectile motion. And if the angle is 90 degree, okay, it's either it is going up or going down, so it is categorized as free fall. But let's go to the basic equation for projectile motion. And the most basic thing that you have to know for projectile motion is, when it is moving, when an object moving with projectile motion, there will be no acceleration in x-axis, and also there will be acceleration in y-axis, always under the influence of gravity. So ax is equal to 0, ay is equal to negative g. Okay, generally when we mention projectile motion, the object is moving in 2 dimensions, that is x and also y. It involves both x and y axis. Okay, so using these linear kinematic equations from this subtopic 2.2, and we have this equation, and when we substitute for both x and y axis class, you are going to have 5 other equations for projectile motion. Okay, and for x-axis you have only 2, is x equal to uxt, vx is equal to ux. Okay, so and for y-axis you have 3, that is sx, vy is equal to uy minus gt, vy squared equal to uy squared minus 2gsy, and sy is equal to uyt minus half gt squared, Okay, so as we know that all the quantities of velocity, displacement, and acceleration are vectors, so we need to consider the sign convention. For the sign convention, for subtopic 2.2, v plus means the object is going upward, and or it is moving to the right for x-axis, and for negative velocity it means that it is moving downward or to the left, And for acceleration, if it is positive, it means that it is accelerating. Okay, the object is accelerating or it is speeding up. And for negative, acceleration negative, it means that the object is decelerate or it is slowing down. Okay, and for subtopic 2.3, okay, we have SS and Vx, and also Vy, Uy, and Sy. So for x-axis, it's more or less equal to this sign convention. The meaning is just equal. But for y-axis, we have, if our Vy is positive, it means that the object is moving upward. If it is negative, it is moving downward. Okay, and for displacement, if it is positive, for Sy positive, your final level is above your initial level or starting level. And for Sy negative, it means that your final level, the final level of the object is below initial level. Final level means where the object stops. Okay, and for acceleration, we already have the situation where for projectile motion, we have Ax equal to 0 and Ay is equal to negative g. So I think that's all that we need to consider, or the summary of chapter 2, kinematics of linear motion. Thank you.